Hello. So thank you all for being here today. I'm very excited to be speaking again at this year's NI DevConf.
Sorry, can we turn off the microphone now? That's going in there.
Oh, I can do two. I can do both. Yeah, so sorry, start again. So welcome to NI DevConf. Very excited to be speaking again this year. Even more excited to have the first slot because then I can relax the rest of the day and not be panicking and worrying. So a little bit about myself. My name is Chris Laughlin. I'm a lead UI engineer at Rapid7. I build a web app that scans web apps. It's very meta. I contributed to the README of an open source project once, so now I'm an open source contributor. I wrote one article for SitePoint, so now I'm a SitePoint author, and I appeared on a podcast once, so now I'm a podcast guest. I like to think of myself as a jack of all trades, master of none, and that photo is the worst hang I've ever had in my life. So today I'm going to talk about security and NPM dependencies and how that ecosystem kind of fits together. But first, I'm going to kick us off with a little story. So a couple of years ago, I woke up at 3 a.m. My phone was buzzing, going crazy. Our Datadog and alerting systems were triggering errors and notifications. And so we logged in, checked my phone, customers were reporting problems. Our Amazon account was triggering, going off, like the servers were going full percent. I started freaking out, worrying, right, we need to go investigate this. So I jumped on my laptop, started doing some investigation, looked at our web application, realized it was running really slow. Got loads of notifications from our customers saying that the site had actually been flagged to them as malware and viruses. Logged in their Amazon account, all our servers were at 100%. The bill was skyrocketing. Started freaking out, being like, right, something's wrong, something's broken. It worked the day before, so logically the first thing to do is I'll roll back to the previous version. So roll back, redeploy, retest, nothing had changed. Still running really slow. I checked our network requests. They were firing off random payloads to different servers that we didn't control and own. Customers were still complaining that their own tools were flagging our site as malware. Really disconcerting. We had to go in, lock down our Amazon account. Someone had actually hacked into the Amazon account. So after battling this, redeploying, nothing had changed. I decided then, right, it's time to give up. Took down the site, threw up a banner. We'll reinvestigate this the next day. So what happened? So next day, we come into the office, we start investigating. We realize that a third-party dependency, so an NPM package that's quite well known that is used for compilation and transpilation of JavaScript, had been attacked, and the source code had been injected into that allowed to take control of your JavaScript. So at build time, it was adding the keylogger to all of our inputs in our forms. It was adding a cryptocurrency miner on the site, which caused the slow connections and the random network requests. It also harvested up all the data that was on the server that was building our application. So it sucked up all our Amazon authentication tokens, our NPM authentication tokens, and that's how someone compromised our Amazon account. But I have a confession to make. That story was fake, completely made up. But it could happen, and it has happened to people before. With the ecosystem we have at the minute with JavaScript, and the technology and the tools that are readily available to bad actors, this is something that could potentially happen to anyone who builds a web application. And at that point, when I was thinking about this story and making up this lie, I'm sorry I lied, but I thought to myself, when we build in web applications, we write our code, only 10% of that code that you deploy is code that you've written yourself. You're taking 90% of that code you found from NPM or found some third-party source, and you're pushing it up and you're giving that to your users. You blindly trust it, you don't know what it does. And it's how we think about and how we manage the code that we release and deploy. So, as I was saying, like, that was a fake story, but this has happened, and there's been cases like this before. I kind of want to take a look through some instances that have happened in the past. So let's have a look at some instances, where NPM packages have been compromised and have caused problems. So the first one we're going to look at is a package called ESLint Scope. So if you're familiar with modern web application development, you'll have heard of ESLint. So it's a tool that allows you to do style checking, moderate your code. It can also apply small changes to your code. So if you forget to put a semicolon at the end of a line or take a new line after an if statement, it can modify your code for you. So this tool has access to read and write your code. but you can't control it. You don't know what it does under the hood. So the incident around this package, it was discovered on the 12th of July, 2018. And then, so what do we think about the impact of this? So the impact was around about 10 million weekly downloads of this package have occurred. So if you think about that attack vector of all these different projects using ESLint, which then depends on ESLint scope, we're all being delivered this attack, and it's spreading across. And that's not potentially 10 million people using it, but it's 10 million builds, installs running all the time. And what was the aim of this attack? So the main aim was to steal data from the NPM RC file in your project. So again, if you're familiar with modern web dev and using NPM, you might configure some things in your NPM RC file. So usually it'd be an internal private repository that you might use. But it's also at build time, the NPM CLI tool can inject authentication tokens into your NPM RC. And the main aim for this was at build time and deploy, they would harvest this data and then use that to compromise other packages that you may be a contributor onto and help spread this kind of worm virus. So then the entry for this, so the attacker had released a new version of ESLint scope. And in this, it would add an install script. So if you've worked with NPM scripts before, you have like your normal start, dev, test, whatever. But there's also an install script, and this runs after you've installed the package, so after it's downloaded the source from NPM. And in this case, well, in most cases, that's used to kind of just build some binaries, maybe pull down some tar files from a server if you're using like a tool that needs installable code. But in this case, what it was doing, it was fetching code from Pastebin, evaluating that code, and then that code was harvesting all this data and sending it off to a third-party server. And the entry for this was one of the main contributors to ESLint scope. Their login details for another service was compromised, and they stupidly used the same username and password for their NPM account. Luckily enough, the attacker in this case wasn't good at writing JavaScript and didn't close off a stream pipe. So whenever it tried to send the data off to the third-party server, the actual code would just fall over. So it meant then for a full day, when people tried to run an NPM install, the build would fail because it was trying to do this as part of the build process. And it was quickly discovered and pulled out of the source. So in this case, what are the kind of methods we use to protect against this? Very easily, like two-factor authentication. We use two-factor authentication for email. Why not use it for something like NPM? We're reading personal emails, but we're also shipping code to millions of people a day. And it's very easy to configure and do. You can do it through the command line. And in that case, it would have prevented this from attacking. Even if they got the username and password, they still need the authentication token. And another one is to ensure to lock down all the versions of the packages you use. So I never used to do this, and then I got bit in the ass many, many times. But I used to always say, right, give me the minor and the patch version of a third-party dependency. And that was great until I realized I was shipping code that I didn't know about because it was constantly changing. The code that I had in my machine could be completely different from what's being pulled down from my development server. So now locking these down, you ensure that you only get what you know you're getting. It has the overhead of having to manually update things, but I'd rather have to manually update things or never update them in general because I know it works, than potentially compromise our experience for our customers, especially coming from a security team that looks pretty, really bad. So then the next incident we're going to look at is from a package called Eventstream. So Eventstream itself is it's a wrapper around node streams, and like node streams is another topic they kind of look at itself. It's kind of like sending data in and around your applications. So this was discovered on the 26th of November, 2018. However, it'd been in the wild for 2 months before it was finally noticed and discovered. Again, quite a big impact here, so around 1 million weekly downloads of this package. And it's one of those kind of packages that's always dependent on something that you don't know depends on it. So you may be using a well-known compile or bundler tool that might have a dependency that has a dependency that has a dependency on this. So that's why it went unnoticed. No one really knew what was going on. So then the aim for this was a very targeted aim. It was to steal Bitcoin wallet information from a specific company. This was like Dash Copay was the company. And it was very targeted towards them and what they were doing. So the entry point for this was a very interesting one. It wasn't someone hacked in and did something crazy. The owner of Eventstream simply handed the package over to the attacker. So the creator of Eventstream had built this package. It was well used, well recognized. then kind of changed focus and wasn't working on that kind of side of things anymore. The attacker, seeing that this package was well known and well used, and it would fit into this attack on the Bitcoin wallets, decided, right, I'll just ask for access. Say, oh yeah, I want to maintain your project, I want to make improvements, that kind of thing. And the owner was like, well, I don't care about this anymore, it's not my problem. Here's the keys, work away. And then with a few days later, the bad actor in this case pulled in a third-party dependency that had the attack and published that out. And the attack itself was quite interesting. He realized that the Bitcoin wallet was like an online Bitcoin wallet management tool that had its own JavaScript library. So the attack was overwriting the prototypes inside that framework to send off the Bitcoin wallets to a third-party server. So in this case, what is the protection we can do for this? So again, there's a kind of running theme. Lock down your versions, have a package lock file, set what version you want to use, and manually update things once you know that they're safe. And then the second is not really kind of physical advice to do, but it's kind of an ethos of how do we maintain ownership of packages. In this case, the original owner of Eventstream got a lot of crap online because they just handed it over to someone who was going to do bad things with it. But is it your responsibility once you build something that people use that you have to maintain this for the rest of your life with no return in this investment? That's not a maintainable kind of option. And it's how do we manage ownership of these repositories? How do we move them across? Is there a criteria if we're moving ownership to someone else? Do they have to fit some sort of recommendation, or is there a way to vet people who can manage packages? And thinking about how we securely build things, it's not potentially the person's responsibility to make sure maintain is secure. I'm sure everyone in this room has that one password they reuse everywhere else, or it's probably been compromised on have I been pwned, and you just don't think about it anymore. Security is a hard thing to continuously manage. So next one, CrossAmes. So CrossAmes is a package that helps you manage and deal with environment variables in your application. So you may set environment variables like environment equals production if you're building production style code, or you might also set up Amazon authentication tokens. So harking back to that story, you could potentially compromise tokens if they were in the environment variable. So this is discovered around the 2nd of August 2017, so a long time ago, but it's kind of shown how NPM security has matured. And the impact for this now very small, but very targeted as well. So around about 700 downloads in total, but the same attack was used on 40 different packages in the repository. So someone had realized this attack was possible and then tried to replicate it across different packages. The aim for this, obviously, the package deals with environment variables. So the main aim here was to hoover up all your environment variables, send them off to a third-party server, and then potentially compromise any API tokens that you have, manipulate data, steal information, all that kind of stuff. The entry for this is another interesting one. So this is a fake package name. There is a package called cross_ems, which is maintained and owned by a very well-known JavaScript teacher, guru kind of guy. And it was only because someone had seen CrossAmes without the underscore, pinged him on Twitter, says like, is this yours? Is this a problem, that it was discovered? And this is kind of going back to the days whenever the web was growing, people were doing typo squatting, so BBC with 2 or 3 C's, and it would take you some dodgy website that you probably shouldn't be looking at whenever you're in work. And this is such a simple attack. So someone would fat finger type CrossAmes, or if you were telling someone about, oh yeah, this is really good package, CrossAmes, you're not going to say cross_ems. Like when I talk about React DOM, I don't say React_DOM or React-DOM. So it's easily, type in the wrong one, pull it down. And the beauty was it did what the other one did, so they just carbon copied the code because it's open source and it's free. But it also then was sucking up all this data and information. So protection for this, a kind of simple one is check what you're installing. It's very easy to quickly say, right, npm install blah package, and not think about what it is, where it came from, who built it. Look at the package page on the npm site. Look at the author. Is there a lot of downloads? Look at the Git repository. Is there a lot of stars? Do things match up and link up? Is the author on npm different from the author on GitHub? Is the community known package? Think about how you pull this information in. If someone emailed you some code, you wouldn't just blindly drop it into your application because it's probably going to do something bad. And then another kind of cool thing is NPM seen this, started growing, started thinking more about this and said, right, we'll now add name checks whenever you publish a package. So if you try and publish a package, it's going to check the name against existing packages and reject that publish. And you can't distribute that if there isn't a genuine reason why you would have that name, but it stops this kind of easy typo squatting, and allowing people to download the wrong package. And then this is a kind of a bonus one that was only discovered and released this week, so just in time to add to the slides. So the package is ElectronNativeNotify, and simply the package itself is just a simple wrapper around the browser's notification system. It is kind of useful, like it's a nice cleaner API, but it's not a huge improvement in what you could have done before. So someone had kind of thought, right, well, we'll just build this package out. And it was trusted at the beginning. So obviously it was discovered on the 6th of June this year. The impact, again, a very small impact because it was discovered so quickly. It was only around 600 weekly downloads. But the aim here, again, is steal this imaginary money that everyone seems to be going crazy about. So stealing Bitcoin wallet information, and it's estimated whenever they prevented this attack from going through and recovered all the data, they managed to recover $13 million worth of Bitcoin, which is a big win for the NPM security team and a kind of big thing to celebrate for them. So the entry for this, same as what we've seen before, releasing a new version of a trusted package. So the ElectronNativeNotify, which is very hard to say quickly, was added to this tool, which was an online Bitcoin management wallet tool. It was used by a lot of people. You could manage different coins, that kind of thing. And then a few days later, someone bumped the dependency of that, but it was a patch version, so it automatically got pulled in. And again, it was interacting with the prototype of their JavaScript library, taking the wallet information, and then firing it off to a third-party server. And unbeknownst to everyone, this was going on. But the funny thing is, the wallets did get stolen, but to get it back, the NPM team used the same attack, and they released a version to the attacker's wallet, which then was harvesting the data back. So they managed to recover all the wallet information, and now it's been secured and been given back to the original owners. And again, simple version in here. So lock down your packages. This is the kind of theme beforehand. I stupidly never did this before, and stuff would break all the time. And the argument now of it works on my machine is not going to work whenever $13 million of money has been stolen from your company and potentially your users as well. So always think about locking down your versions. There's the overhead of manually upgrading things, but I'd rather manually upgrade something than have to, leave my job because I've lost the company $13 million. So scary stories aside, incidents aside, what are the things that we can use to improve our workflows, to manage how we do our security when it comes to third-party applications, NPM packages, that kind of stuff? Probably the most simple and easiest to use is the NPM Audit CLI tool. So it's bundled with NPM version 6, and it's really handy that it runs automatically for you after you do an NPM install. So you might notice at the bottom of your terminal, after you've run an NPM install, it'll print out how many high, medium, low vulnerabilities you have in your package. I always ignore them probably, but well, that's another day. And what's kind of cool is it runs on not just like your normal bare dependencies, it does your dev dependencies, your bundle dependencies, optional dependencies, so it's checking all these different things that are pulling code into your project that you may not know of, understand. It also it provides like an autofix feature where you can just run it and pass it a flag saying autofix, which will just automatically update all the packages to the secure version. I don't always recommend that unless you know what you're doing, because if you're like me, you have that one dependency that's locked in old version because it works like that, and the only way to upgrade it is to rewrite half your application, and we've got better things to be doing with our time than rewriting something that already worked. So it's up to yourself if you want to run that. So this is kind of just an image of what it looks like. So when you run NPM Audit, it'll go through, generate a report for you, listing all the different packages that are vulnerable. And I have like a purposely vulnerable product that I can run this against. So we can see there's 2 vulnerabilities in jQuery. Yes, people still use jQuery, surprisingly. And you can see there's a moderate and a high. And what's kind of cool is it talks about like the dependency of. So this is not only just checking the top level dependencies, it's also going down the nested dependencies for those products. Because in all the examples we were looking through, it was always someone had bumped up a dependency or added another tool, so it wasn't always a direct bump of a main package. So you can get down that deep tree level stack of like this depends on this and this and this and this. Provide some information about them. So one's like a prototype population, and then there's a cross-site scripting attack. So severe enough vulnerabilities that potentially could cause you issues. So then the next one I've been playing about recently is Sync or whatever, it's hard to pronounce. It's a cloud-based solution, which is kind of cool. So with NPM Audit, you're running on your terminal, on your machine, and it's a snapshot of the code that you have there and the dependencies you're dependent on at that time. Whereas we all know, like, you should be pushing something into your source control, and that should be, your source of truth. So with this tool, it's cloud-based. It integrates with all the different source control solutions, GitHub, and well, we only ever use GitHub, so I don't care what the rest of them are. What I like about it too is that it's not just kind of, I'll have to go into this tool and run it each time. It's can do on demand, but it can also do scheduled checks. So it's just going through your package JSON file, looking at your dependencies, checking if there's no vulnerabilities. And it's really nice that it gives you like a weekly report of this, telling you how many vulnerabilities you have on different projects. And then it has a cool little dashboard that shows you all your different projects and all the different vulnerabilities on it. So here's a kind of view of the weekly report that I get. And because I have a vulnerable application, I get it every time, and I'll never fix the vulnerability. So this is my life. So out of the 23 active projects, I still use that word very loosely there, I have 92 vulnerabilities, and then total number of dependencies that those vulnerabilities can exist amongst. So it kind of gives you a good snapshot of the health of your projects and what needs to be addressed right away. And it gives you that breakdown of high, medium, low, which is very useful. And then there's the dashboard view as well. So it lists out all the different projects that you have connected to it. And it has the vulnerability counts for each of those, so you can see which ones you need to address before the others. Funnily enough, every project I have has vulnerabilities in it, so that's great. And then the last one to look at is GitHub itself. So again, we're already using GitHub day to day because that's where we keep all our source control, so why not link something to that? So the beauty about the GitHub checker is it's already linked to your source control, that you can see your dependencies right away. It's got a very good growing database of vulnerabilities. So the main selling point for each of these different tools is the database of vulns that it maintains and which ones they find quickest and which ones they can remediate for you or show you. So the database of this is growing well because GitHub's such a big company and Microsoft recently acquired them, so everything's going to change and all that kind of stuff. And then with the recent release or recent announcement of GitHub's own package repository, there's a potential for integration here. So when we were looking at some of the incidents before, it wasn't potentially someone had, raised a pull request for a dependency or a bit of malicious code. It got approved because no one knew what they were doing, and then it got released through their CI environment. People were grabbing credentials, running a publish from their machine, so they were bypassing the source control completely. So the package you installed potentially didn't match the code that was in its repository. And there's no guarantee with an NPM package which is which. Like I know for some of the packages I deploy, the repo has nothing to do with the actual packages out there because I'm just so lazy and pushing code out. But there's a potential integration here where it can do checks against the source code and can potentially rebuild and reverse build your code to say, right, this matches what's in the repo right now. This is trusted code. GitHub has great security as it is, so if you trust the source code, then you should be able to trust the package. So this is kind of a view of my vulnerable project. Gives you a big, massive banner, so you know right away, yep, this thing's got vulnerabilities, I need to address them, I need to look at them. And then a kind of more prettier, in-depth view of it, so you see it's the jQuery vulnerability, tells you what the version that vulnerability exists in, what version you would need to update to then resolve that vulnerability, and gives you some of the CV vulnerability data kind of information, some more explanation what the vulnerability is itself, which is quite useful. So, kind of in conclusion then, is NPM bad? Is it vulnerable? Is it an evil corporation that doesn't care about security? No. NPM actually acquired a security team to bring in-house to manage and deal with these kind of incidents, and they take security very seriously. But as the ecosystem grows and how NPM started to where it is now, security was only involved by the people who used it and built it. Because we don't think about security doesn't mean that they shouldn't have to think about security. And it's free. Why complain about something that's free? And I think a lot of things are changing now, especially with GitHub announcing their own repository. At JSConf EU recently, there was an announcement that they're trying to introduce like a non-federated repository of packages that doesn't have this one company owning it. And it'll be interesting to see how the security implications are kind of managed through that and how people are going to look at packages and see if they are secure or not. And And then some just general best practices when it comes to security, like two-factor authentication is easy. We all have or Google Authenticator on our phones nowadays because everything we use in work is all secured down. It's just adding another number that you have to type in every time you log into your server or whatever. Simple best practices there. Look at the package you're installing, think twice about it. It's getting that mindset of, yeah, that 90% of the code I'm pushing to my customers, I didn't write that, I don't know what it does. They could be doing anything mad inside of there. And then think as well about how we use packages. The idea of reinventing the wheel. If you get a string utility function from NPM that uppercases a string, you could probably write that yourself instead of having to use something that you don't know what it does. It could be giving you the uppercase string, but it could also be pinging to a server, and you, unbeknown, are now part of a botnet attacking sites. So, perfect timing. Hey. Thank you. Any questions? Yeah, go ahead.
Have you had a chance to check out GitHub's new acquisition, the company Dependable?
Yes, so I haven't played about it too much, but I got an email the other day that it was trying to update my dependencies, so I must have signed up for it somehow. But I like the idea that it's like an automated tool that it can raise a PR and update it for you. Security concerns around that as well, though. So there was a tool, I can't remember the name of it, but there was a tool that went bust like a year or so ago that did the same thing. You would give it contributor access and it would raise a PR, and you could tell it to also like auto-merge the PR, and then someone hacked that company and sort of then used that to go and take ownership and inject code into every project that it used. So it's kind of letting someone in the front door, but do you fully trust them?